Okay, so this is a high-speed run-through on DC generators. Before we move on to look at that, you're going to need to know Fleming's right-hand rule for generators. So step one, let's have a look at this arrangement here. We have a single loop conductor placed within a magnetic field. If we apply a mechanical force to this to rotate it, it will generate electricity and it will produce something like that, hopefully tidier. So this one single loop rotating within a magnetic field will produce AC. Okay. So if we look at a similar scenario and we take a single loop within a magnetic field, but now on the end of the shaft of this particular generator, we're going to insert a commutator. For every loop that we have within the magnetic field, each end must connect to one segment of a commutator. So the commutator is a switching device. I'll come back to that very shortly. This particular arrangement will produce this. And so it will carry on. And what is happening now is the commutator, as the switching device, will maintain the direction of current flow. Every half revolution, there's half a revolution. Every half revolution, the commutator keeps the current flowing in the same direction. So this is all positive. This is DC, but it's not very usable. It's very lumpy. It's not smooth. So this was a single loop generator. If we were to add one more loop, that would mean having 4 segments on the commutator now. Then that new loop would produce this. So if I try and explain what is happening now, because this looks a bit of a mess, the commutator will have this particular loop within the coil. And then it switches. The next set of segments on the commutator will come into play and they'll allow the output from that particular loop to conduct. And then we switch to the first one, and the second one, and the first one, and the second one, and the first one. So the DC output has now much less ripple. And that was just with 2 pairs of conductors. So if we were to up this to an industrial scale, a usable generator, and we had, say, 40, 50 or more loops within there, then we would hopefully get an output that would look something like this. A nice flat DC line, and that is what we're aiming for. So this is DC. We have a commutator. AC, there is no commutator. In a commercial AC generator, this would have slip rings on it. Slip rings AC, commutator DC.